Pipebots is a large investment from the Engineering and Physical Science Research Council to develop micro-robots, which can inspect a massive network of buried pipes pervasively and on a massive scale.
Pipe networks, probably 1 million kilometres in the UK, so it's really a challenge to understand the condition of individual assets or pipes or chambers.
Leakage is a massive problem. It is pointless treating water, putting it in a pipe and then it not reaching where it's going. It's a waste of resources, it's not sustainable, and with the water crisis that's coming on, we don't want that. We want to find those leaks. Pipebots is a very interesting way, a new idea about how to find those leaks.
By being able to understand where defects are located, where blockages are located, their size and characteristic, you can much better manage your networks. But you need to have this information over the whole network. So it means that pervasive sensing, low-cost sensing is really, really important in order to be able to manage your networks well.
The micro-robots we develop, they're going to be autonomous. We can send them in the pipe network, and the robots will just progress through the pipes. So they will find these faults, or they find the signs of the pipe deterioration which lead to these faults, and report back to the center. So the water companies can send teams of engineers to fix these problems before they develop into big problems.
Pipebots is really interesting for me and I think for the sector as a whole. I've been involved and tracking the development of Pipebots since the very early days, and I was involved in that original project. So it has a special place in my heart, and now it is really about tracking the developments and understanding the impact that it could potentially have from an innovation perspective, but also the environmental, financial and societal benefits that we will see as a result of a successful delivery of Pipebots.
I'm interested in the Pipebots because it is an alternative solution for finding leaks. My personal history is that I've worked on acoustic leak detection, which is listening for the sound of the water escaping from a pipe. So we're always on the lookout for looking at new ideas about how we can find those leaks.
This area on robot localization and mapping is really important because you have to know where the robot is. If it detects a defect and someone has to go and repair that defect, they need to know where they're going to go to repair it. And that might involve things like digging up the street. And people have often experienced disruption on the road in traffic, to people blocking off the road to repair underground pipes. And it's really important that people dig in the right place to repair those pipes. It reduces disruption and it costs less and it makes people's lives a lot easier. The reason that we're really interested in acoustic data is that if you think about a pipe, it's a dark environment. Okay, so cameras aren't best suited to that. You have to take a light source with you which consumes power, so it's not very energy efficient. Acoustic waves, on the other hand, are not affected by light or darkness. They can travel long distances down pipes and reflect off objects that are quite far away that you wouldn't necessarily be able to see nearby. Acoustic waves can also travel around corners as well. So you can effectively kind of see around corners in the pipe network, which is really beneficial for localization.
We run industry workshops to present to the industry the results of our research and to obtain feedback on the best way how to proceed to make sure that we develop impact. So the research doesn't stay purely academic, but benefits to the society, environment and the economy.
Pipebots Industry Workshop has been held in ICAIR because we've done a lot of the technology development in ICAIR, because we can test the Pipebots technologies at a full scale, because people can come from industry, see full-scale devices in full-scale pipes subject to realistic pressures, and they can appreciate the realism of the environment, which is really quite unusual at this type of technology development stage.
It's been very interesting today to see the presentation about the different parts of technology within the Pipebots project, because generally communications doesn't work underground. It's clearly there's the thinking to solve all these different problems to bring together a solution that works in the end.
So our technologies that we're developing can be, broadly speaking, translated to other domains where you don't have GPS signals. So that could be potentially very deep undersea, or in mines, or in tunnels, or off-world, on Mars maybe, where there is no satellite system available for GPS.
It has the potential to be truly transformative, and that's where we are now. In terms of the challenges we face, we need some of those really truly transformative solutions to come forwards. This could change the way we assess the condition and prioritise investment into our buried infrastructure. It takes humans away from the need to be going down into dangerous environments, and it just gives us the insight and the foresight to be able to head off disasters and to better manage our network so it becomes more resilient in the face of climate change. And we all need to adapt and change when we think about the future and the scenarios that we're facing, and this will play a huge part in helping us build that resilience.
Let's not dig a hole in the road. Let's not have all that disruption, let's have it fixing itself. And I think by having a robot there, you're adding that as an extra dimension.